Okay, so hey guys, I think we've got a pretty sweet talk for you coming up. David Sugar is from Aalen University in Germany, and today he's going to talk about implementing a FIDO2 authenticator in Zig. David also has given some very high quality patches to the Zig embedded group repositories, so far he's my favorite speaker.
So, thank you for inviting me to speak here. So, my name is David, so I'm talking today about implementation of FIDO2 in Zig. So, I'm a student and also an academic staff at a small, or no, that's not the right word, but a smaller university in Germany. And short disclaimer, I have absolutely no affiliation with the FIDO Alliance or any other organization that has anything to do with FIDO, so this is just a hobby of mine. So before we start with FIDO2, I want to quickly dive into authentication in general. So for authentication, there are more or less 3 different approaches. One is knowledge-based, so where you where you know something that nobody else does. So this is typically your password or your PIN for your credit card, and by providing this secret information, you can authenticate yourself. Another way is possession-based, so where you own something. This is maybe your smartphone with a one-time password app on it, and the third one is inherence, so where you provide something that is inherent to you. So for example, your fingerprint or your iris. So, and up to this day, the most popular authentication method is passwords or PINs. So this includes, for example, accounts, so for operating systems, credit cards, web services, or even access control systems. So at our Airbnb, there is a PIN pad at our log, and then we enter a number, and this, if the number is correct, it grants us access. So, but the problem is that there are some downsides to passwords. And one is that they must be increasingly complex. And also, one recommendation is that you don't reuse your password, and that makes it really hard to remember them. Usually this leads either to reusing passwords, or you just pick very easy to passwords that are just easy to remember. And both approaches are quite bad. So another problem is if a company has a data leak, maybe stored password hashes get also leaked, and if the company didn't choose a good hashing algorithm, those hashes might get broken. And then there is also that passwords might end up in log files. So, for example, you want to log into an online account, enter your password into the email field, click login. This might end up somewhere in a log file, which is also not good. And last but not least, one problem is users might fall for social engineering or phishing. So where somebody else, an attacker, tries to convince you to provide him with some secret information, so in that case, your password. Because of all those downsides, people came up with the idea of a second factor. Sorry for that. There's also yeah, sorry. No, they came up with the idea of a second factor authentication. So where you're not just providing one factor, so for example your password, but also a second factor. This like for example a one-time password you receive via email or SMS. But so this can absolutely help mitigate attacks. But some examples from last year have shown that this can be circumvented. So one is Uber. I just put Uber in here because they wrote a nice article about what really happened. So, but there are other companies that got attacked as well. One is, I think, Rockstar. So, and another aspect of authentication in general is so every step that you include in the authentication procedure just worsens the user experience. So, and this is just my opinion, but I would say that authentication should be quick and painless. So for example, if I want to use a PayPal, I want to buy something, it shouldn't take a few minutes to sign into my account, then get an SMS OTP. Maybe that OTP didn't arrive, so I need to click resend, so this isn't that great of an experience. So then when I think about authentication, so what if I want, what should authentication provide? So users shouldn't be responsible for details like password complexity. So I think this is something that should be the concern of the developers and not the user. And then it should, of course, be fast and secure. And secure, of course, depends on the implementation. But in general, I would say, in a general sense, I would say secure in that case means an attacker shouldn't be able to easily bypass the authentication procedure. So the question becomes, are there better solutions? And the answer is there might be. So, and this is what I'm going to talk about. So it's called FIDO2, and it's driven by the FIDO Alliance. So, and they say on their website, the FIDO Alliance developed FIDO authentication standards based on public key cryptography for authentication that is more secure than passwords and SMS one-time passwords, simpler for consumers to use, and easier for service providers to deploy and manage. FIDO authentication enables password-only logins to be replaced with secure and fast logging experience across websites and apps. So FIDO2 or FIDO started actually, I think, as another second factor, but they moved their goal towards replacing passwords. So where FIDO2, the protocol, becomes a single-factor solution for authentication. So, and so FIDO2 uses public key cryptography so digital signatures for authentication. So quick introduction to public key cryptography for everybody who might not be into that kind of thing. Compared to symmetric cryptography, where you have a single key, which you can use to encrypt something and then decrypt it later on, you have a key pair, which consists of a public key and a private key, and you would just, so say we want to encrypt hello world, so we would use our public key, encrypt it using that public key, get a ciphertext, and later on, we could then use the corresponding private key to decrypt it. So if we use the public key for encryption, we usually want to keep something secret. So because the public key is meant to be shared with anybody else, and the private key is kept to the person who generated it. So everybody can encrypt something with the public key, but only one person can decrypt it. But we can also go the other way around. So, sorry. We can go the other way around. So the person who owns the private key can encrypt something with it, and everybody with the public key can then decrypt it. And this encrypting with the private key is usually referred to as making a signature or a digital signature. So how does it work? So we have say two parties, 0 and Amber, and 0 wants to submit, or Amber wants to make sure that the message she got from 0 is really originated from 0. So they can, before they exchange messages, they can, 0 can submit his public key to Amber over a secure channel, and then 0 can encrypt the hash of a message or the message he wants to send to Amber using his private key. And then send a tuple of the signature C and the message to Amber. And Amber can then use the public key here she received previously to decrypt the signature and then compare it to the hash of the message. And if both matches, then the Amber can be sure that this message was really generated by 0. So FIDO2 uses this digital signatures for authentication, and it's split into two sub-protocols. So we have, on the right-hand side, we have a relying party. So this is the server you want to authenticate to. So for example, some web server. And on the left-hand side, you have an authenticator. So this can be some software running on your PC, but it can also be some piece of dedicated hardware, like a YubiKey, for example. And right, and so say we want, and in the center we have a client. So this is can be seen as a man in the middle that passes messages between the relying party and the authenticator, and the client can, for example, be your web browser. So say we want to use FIDO2 for authentication. The first step is to sign up to a service. So we usually would, for the sign-up phase, we would use email and password, but for FIDO2, we would just provide a username or password and then submit that to the relying party. That would generate a challenge, so this is just a random number, and pass the challenge together with some other data to the client. The client then pre-processes those data into a so-called client data hash, and then makes an API call to the authenticator saying, hey, here's some data, please make a so-called credential, which is public-private key pair combined with an ID and some other stuff. And the public key is then transmitted back to the relying party. And the relying party then stores the public key and its ID. So now, if we want to authenticate ourselves, we can then just provide our username, click sign in, and the relying party again generates a challenge. The client pre-processes the data it got from the relying party and then makes another API call, which is called Authenticator get assertion, which just tells the authenticator, hey, here's some data, please sign this client data hash. And the relying party ID, which gets also transmitted, is usually just a base URL. So if you want to sign into your Google account, this would be www.google.com or something like that. So the authenticator then just looks up the corresponding private key, signs the data it got from the client with the private key, and returns the signature. And the relying party, because it got the corresponding public key, it can then easily verify if the signature is correct or not. And this is a very basic overview of how FIDO2 works. So there are some advantages to that. So I can't go into details, but so one is that for every relying party, there a new unique keeper is created, and the public key is stored on the server, which I think is a little bit better than storing a password hash, because if you leak your public key, you can't do really much with that as an attacker. Another thing is it's quite easy to use, so you just click sign in and then present your authenticator. And you can also additionally protect an authenticator by a PIN, which is essentially a password. So, so let me quickly check the clock here. So when I started the project implementing FIDO2, so a CTIP2 authenticator, I wanted to implement it in a way that it can easily be reused. So that somebody can take a FIDO2 library and then implement an authenticator with it for example, for Linux, but also use it to implement an authenticator on an embedded device and play with it. So in essence, you can split the whole FIDO2 protocol or the CTIP2 protocol, which is the part for the communication between client and the authenticator, into 3 layers. So we have the application layer. This is just API calls. So, hey, make a new credential. Hey, sign this data. Then there is an encoding layer. So the client and the authenticator need to communicate somehow with each other. And this is done over using the CBOR encoding, which stands for Concise Binary Object Representation, which is comparable to JSON, but for binary data and more compact. And then we have the transport layer. So currently there, the FIDO2 or the CTIP2 specification defines 3 different transports. One is USB, NFC, and the last is Bluetooth. So unfortunately, currently there is no specification for how, for example, to the authenticator and the client, if they run on the same device, how they should communicate with each other. So this part is unfortunately missing. So, right, and the goal was so that the library also supports the transport protocols. So not USB, but the protocol that builds on top of it. So in that case, for USB, that would be CTAP HID, which just uses USB packets to transmit data to the client. So this is just another quick overview of the layers. So the idea was the library provides the upper layers, and the user, if you want to use the library, just provide some callbacks so the library knows how to do things like generating random numbers, access a new file system, and stuff like that. So this is what I was talking about. So if you would say, so now you want to use the library, so the current, this code is this working code. So the first step for using the library at the moment is you need to create an authenticator. So the first step is you need to provide a few settings. So this just describes the capabilities of the authenticator. At the moment, this is quite limited, but I support a good chunk of the specification. So, for example, we provide a version. So, which FIDO version do we support? A unique ID to our authenticator, or to the type of authenticator we provide, and then which is probably the most important thing, the signature algorithm to use. So here it's ES256, which is elliptic curve digital signatures over the curve P256. Right, after you've provided some settings, this is the hard part, so you need to provide a lot of callbacks. So the authenticator needs, or the library needs to know how to generate random numbers, how to get a timestamp in milliseconds, and also interact with the user. This is the UP callback. So so part of the specification is that you must physically interact with the authenticator to proceed, for example, making a signature. And we also need to provide a way to do that. And we can also secure our authenticator using a so-called PIN UV auth. A PIN. We use a PIN. So this prevents others from using our authenticator. So the worst case at the moment is you lose one of those and somebody finds it, plugs it into his PC and logs into, I don't know, Amazon and goes shopping or something like that. So and to prevent that, you can set a PIN, or the alternative is to, for example, have a fingerprint reader or something. So, and after you have created an authenticator, the last thing you need to do is you need to communicate with the client. So, for example, in that case, we use USB, and then in that case, we just have an infinite loop and just pull USB. And if you get a packet, we just pass that packet to a CTAP HID handle function, a message and a reference to authenticator. And the handle function just incrementally, in that case, builds a message from the packet it receives. And if it has resembled a whole message, it will just pass that to the authenticator. The authenticator then handles the message and returns a response. And we can then take that response. In that case, it's an iterator, and just iterate call next in a while loop, and just send the CTAP HID packets out using, in that case, USB. So this is how you would use the library. So why did I choose SIG? I think one reason is SIG already provides a solid foundation of cryptographic algorithms in its standard library, which is pretty nice. So we have signature algorithms, which I need. We have hashing, and we have encryption, and even and we have also SIG, the standard library, provides some data types for elliptic curves. So, for example, I haven't looked. So when I started it, for example, there was no implementation for Diffie-Hellman using the elliptic curve P256, but it was pretty easy to just get something, just implement a basic Diffie-Hellman using a few lines of code. So I just reused the code that was already there in the standard library, and this is just to generate a shared secret. It just gets a secret key, which is a number, and an X and a Y coordinate, multiplies that together, and we have a shared secret. So another nice thing is that SIG supports cross-compilation, so we can easily, for example, implement an authenticator for Linux using that library, or you write an authenticator that runs on a Nordic chip. So both things lead to working implementations, so specific implementations of authenticators. Yeah. And the last thing, how one can read it. So it's pretty easy to generate code at compile time. So another thing what was missing when I started was a CBOR parser, or a serializer, deserializer. So, but it's quite easy to write a general parser that just gets some SIG data type and some CBOR data in that case, and returns or that translates some CBOR data into a SIG data type. So here, that probably looks quite similar to the JSON implementation. of SIG. So we just get an arbitrary SIG type and a data item. So a data item, you can think of it's just a wrapper around a byte slice, which represents some CBOR data. And we can then, and some options if we want to tweak the behavior of the parser. And then you would just switch over the type. And for example, if it's a struct, we could translate a CBOR supports, for example, a map, so it's just key value pairs. And we could just translate that into a CBOR, into a SIG struct. So we would then just ask if the data item is of type map, and if it's the case, we can just iterate over the single key value pairs of the CBOR map, and then also look for a corresponding field in the SIG type, and if the key and the field name in that case match, then we just recursively parse the data item. So, and because CBOR is usually they recommend depth of about 3 or 4, it's not that bad to do it recursively, I think. So, and at the end it looks like this. So, for example, make credential would be the struct, and then we have a data item and just pass a byte slice to it, and maybe an allocator. So this is probably necessary if the struct contains slices, so that the parser can allocate memory for the different slices, and then hopefully we get just a SIG type at the end out of it, and that's quite nice. So that brings me to the end. So I think authentication is something that won't go away, and it's part of our daily life or our online activities. And unfortunately, at the moment, especially with passwords, there are many pitfalls. So I think FIDO2 could be a better alternative to passwords. So it's not perfect. That's not the case, but it could be. You could exchange. So you could exchange a set of problems with a set of other problems that are maybe more manageable. But at the moment, I think a few things that hinder FIDO2 at the moment from widespread adoption is it's pretty expensive. So if you want to use a hardware authenticator like a YubiKey, that costs about $50, and they recommend you use 2, and then it's hard to convince people to spend $100 on authentication. This is a problem. Then there is the missing IPC spec for platform authenticators, which I don't understand really why they missed that part. So at the moment, if you want to use a platform authenticator, you either have to do some trickery, which I did with creating a virtual USB device on Linux, and then just pretending as if you're a hardware authenticator or an authenticator connected via USB. Or you use, I think, Windows Hello supports FIDO2 since a few months, and also I think Google or Android. So, but yeah. And another problem is, and this is a major bummer, is some browsers and a lot of websites lack support for FIDO2. So, and the problem here is that you have 3 different parties who all need to get it right so it works together. And if if they divert from the specification, that can lead to the situation where you buy an authenticator, but it works with some services, but not with others. And so, for example, the current Authenticator implementation for Linux currently works, for example, with Codeberg. This is just some version similar to, for example, GitLab, but a similar web service. But it doesn't work with a similar web service because it does some weird stuff I haven't figured out yet. So this is a huge problem. So from my perspective, of course. So what I think currently is missing a platform authenticator that you could love. And yeah, if you want to participate on the project or just check it out, you can find the project on GitHub here. And yeah, then I will end up with a short presentation. So this is Codeberg. This is similar to GitHub or GitLab. So and currently it only supports FIDO2 as second factor. But so here I have just my Authenticator application running. And then I can try to log in. Sorry, that takes a moment. Ah. So now it has recognized the authenticator, asked me for the PIN I set for the authenticator, so I enter that. And then I need to physically interact with the authenticator, so say yes. And then it will sign the hash it got from the client and then sign me in. So this is... So, any questions?
Okay. I gotta say, I just got into making synths with microcontrollers, but now hardware authenticators are looking pretty enticing.
Yeah.
Yeah. Any questions? Oh, we got a thing right here.
You mentioned that hardware devices were like pretty expensive.
Yeah.
And you have a software implementation, well, mostly software implementation here. Do you know the reasons why the hardware versions are like harder to produce or more expensive?
Why they are more expensive? So they are not all expensive. So for example, you can get a somewhat good authenticator for $20. But and the reason is just it's a cost, it's a hardware cost. So yeah. So and for example, if you want a fingerprint reader on your device, then it bumps up the price by, I don't know, $20 or something.
All right, fair point.
One note, so maybe that's an opportunity, like take ESP32 for like 50 cents and do something, maybe?
Huh?
Maybe we can take an ESP32 and for 50 cents and sell to the world.
Yeah, good
Zig
point.
supports that, right, Matt? Right, guys?
Yeah, so that was the idea with the with the library, so that you can just use that library, implement an authenticator for example, for an ESP, and then just play with it around and have fun. And
the other question, the client side, the last time I checked, it requires JavaScript. Is that still the case?
No, it doesn't. Ooh. So it depends. So FIDO2, So FIDO2 is just a spec. So currently it aims at the combination of web server with your web browser and some authenticator. But you can also, I started playing with implementing my own client, so client library. So you don't need JavaScript. You just need to implement the API so that the client can communicate with the authenticator. And this is usually done from server side, it uses JavaScript, but it's not necessarily required.
Okay, so let me put it another way. Is it possible? Can I make a website which uses the FIDO2 authenticator without JavaScript?
If you implement the client yourself, yes.
Can I implement the client in HTML? Like how did it work?
You could write it in SIG.
That's WASM then, right? Like I have to execute something in the browser.
No. So the client runs on your PC. This is just a piece.
Oh no! Like imagine I write a website. Like I have a website, like a super popular personal website, right? And I want it's like 3 visits a day. And I want to add users there, like add comments or whatever. Currently it's an HTML only thing, like CSS and HTML.
Yeah.
So can I add user? I control the server, but I don't control the browser, obviously.
Yeah.
So can I add users there, which could log in with these hardware things?
So maybe
without JavaScript. With JavaScript, yes.
So the question is, do you want to use the browser for that? Or
Yeah. Well.
Then probably
Okay.
So, but if you want, you could write your own client.
I can write a desktop app. And
Yeah,
then
you could write a desktop app that communicates with your website.
All right. Thank you.
So, I know you mentioned FIDO2 a lot. I was just curious, is this just passkey? This is the underlying part of the passkey, right?
Say again.
I mean, is this just were you just describing passkey?
Passkey.
Yeah.
Key pass.
No, it's called passkey.
Passkey. I think they. I'm not quite sure. It might be that they use passkeys for the credentials, so that they use passkeys in the context of credentials, for example. I'm not quite sure.
So because you also mentioned WebAuth, right? Because the other part is the WebAuth part. And that's what passkey uses. It just feels like you're probably talking about passkey, but you use FIDO2 because I think
so FIDO2 is the whole the protocol, and it splits into 2 sub-protocols. So one is WebAuthn, so where the client, so your web browser, communicates with the relying party, which is your web server, and the other is CTAP2. And together, so WebAuthn plus CTAP2 is FIDO2.
Okay. So my actual real question is, how in your demo, how did you hook to the WebAuth? Because the part where actually it still uses password, right? Did you just use your library to get into the password vault?
No. So at the moment, so if I understand it correct, so the authentic is for example, in that case, Brave or Chrome, expects an authenticator either connected via USB, NFC, or Bluetooth. So in my case, so for Linux, it's called USB Gadget. Where you create a virtual USB device. And the web browser is then just enumerating all USB devices and asking, hey, are you an authenticator or not? And then
You're just pretending that your actual real USB device that's plugged in. Okay.
Yeah.
All right. Thank you.
So very cool library. One question I have is, you mentioned a pure software sort of situation where you're using like Windows Hello or something like that, right? And I'd imagine the key functionality in that case, there's no hardware token. It's just purely on the computer.
Yeah.
And you've got your private key. I'm wondering if there would be a use case, like if you used your library to be able to move that private key around, like an identity almost that you can bring to another operating system or something, if you used your library in multiple places? Or would it make sense just to use a hardware token? I'm just curious if you foresee any use to that, because I can see regular users like kind of putting their nose up, I got to carry around this key now. So like, would there be a suitable way to carry around that information securely?
So I want to compare to password managers, but because I think they are quite comparable. So, and for password managers, what a lot of people do is they store their, so the database that holds all the passwords is usually encrypted. And then they can store that encrypted database somewhere on a file share. And in that way, you could access the database on multiple systems. So something similar you could do with the library.
So theoretically, one could make like a front end for your library and have a key export functionality, and they could store that in one password or something.
Yes.
Okay, cool. Very cool.
Any more questions? Okay, we got Andrew. This will be the last question.
Thank you. That was great. I noticed that in your demo, you typed in your password several times. Do you think that in the future, FIDO could help us not type our passwords in ever?
So I didn't enter my password multiple times. I entered one password for the web service, and then I entered my PIN for the Authenticator. So 2 different passwords. But yes, so currently most platforms only support FIDO2 as a second factor. But the goal of the FIDO Alliance is actually to really replace passwords, where you just enter your username and then click sign in, and then it says, hey, present your authenticator. So you can also set up your authenticator in a way where it doesn't ask for a password. But the question then is, so for example, for a platform authenticator, I would say it makes sense. So because to get access to your desktop, you need to provide a password, for example, and log into your system. But if you, for example, if you lose this key and everybody that picks it up can use it, that's bad. So here it makes sense to either protect it using a fingerprint, but this one hasn't a fingerprint sensor, so you're stuck with a PIN, which is in essence a password. So
That makes sense. Thank you.
Awesome. Put it together for David.